Assalamu alaikum wa rahmatullah. Bismillahir Rahmanir Rahim. In this video we are going to talk about the last type of transformation, which is called the direct plane similitude, and this is the first part. Here are the objectives. Define a direct plane similitude. Apply the properties of a direct plane similitude. First, we are going to define a direct plane similitude. Definition 1. Let O be a point in the plane and theta be a real number and k be strictly positive real number. The transformation that associates to every point M a point M prime such that OM prime equal KOM and the oriented angle OM prime equal theta mod 2 pi is called a direct plane similitude, or simply similitude, with center O, ratio K and angle theta. As you see here in the figure, M prime is the image of M by this similitude. Notation: the similitude with center O, ratio K and the angle theta is denoted by SOK theta. Determination: S of M equal M prime if and only if OM prime equal KOM and the angle OM prime equal theta mod 2 pi. Elements: a similitude has 3 elements: the center, ratio and the angle. Tips: the right figure here, S of A equal AW prime, S of B equal BW prime, S of C equal CW prime. Thus, the image of the triangle ABC by this similitude is equal AW prime, BW prime, CW prime. So in brief, the similitude is the composite of two transformations. First, ABC is dilated into the triangle A prime, B prime, C prime by ratio K, and A prime, B prime, C prime is rotated by the rotation of angle theta, so it will be transformed into the triangle AW prime, BW prime, CW prime. Finally, the triangle ABC is transformed into the triangle AW prime, BW prime, CW prime by this similitude. Remember these remarks. Example 1. Let ABC be a direct equilateral triangle and I be the midpoint of the segment AB. We have 3 similitudes here. S1 of center A and ratio 2 and angle pi over 3. S2 is a similitude of center B, ratio half and angle pi over 3. And S3 be a similitude of center C, ratio radical 3 over 2 and angle minus pi over 6. Here is the figure. Determine the image of I by S1, the image of C by S2, and the image of B by S3. Please try to think before you see the solution. First, S1 is of center A, ratio 2, angle pi over 3. To find the image of I by S1, you must search for a point I prime such that AI prime equal to AI because the ratio is 2, and the angle between AI and AI prime is equal pi over 3 mod 2 pi. This point will be C, so S1 of I is C, and this is because, as you see here, AC is twice of AI, and you can prove it easily because AC equal AB and I is the midpoint of AB, so AB is twice of AI, so AC also will be equal twice of AI. And also you can prove easily that the angle between AI and AC will be pi over 3 because the triangle is an equilateral triangle. Let us go to the second one, S2 of C. S2 is of center B, ratio half and angle pi over 3. S2 of C will be I because by the same reasoning BI is equal to half BC, and it is easy to prove that, and the angle between BI and BC is pi over 3, and you must focus that the angle must be oriented in a positive sense. Let us go to the third one. S3 is of center C, ratio radical 3 over 2 and angle minus pi over 6, so you must search for a point such that CB prime equal radical 3 over 2 CB, and the angle between CB and CB prime must be equal to minus pi over 6. This point will be I. So S3 of B equal I because CI equal radical 3 over 2 CB. And this property returns to the properties of a semi-equilateral triangle. ICB is a semi-equilateral triangle. Here the angle is 30, here the angle is 60, and we know that the side facing 60 is equal to the hypotenuse radical 3 over 2, so CI equal CB times radical 3 over 2. And as you see here, the angle between the two vectors CB and CI is equal to pi over 3, so I will be the image of B by S3. Now let us go to another example. Application 1. Let ABCD be a direct square with center O. I and J are the respective midpoints of the segments AB and AD, And given these similitudes, S1 is of center A, ratio radical 2 and angle pi over 4, S2 be a direct similitude with center B, ratio radical 2 over 2 and angle pi over 4, and finally S3 be a direct similitude with center A, ratio half and angle minus pi over 2, and this is the figure of the question. The first part, determine S1 of I, S2 of O and S3 of D. Please stop the video before you see the solution and try to solve it alone. Let us go to the solution. First, S1 is of center A, ratio radical 2 and angle pi over 4. To find the image of I by S1, you must search for a point I prime such that AI prime equal radical 2 AI, and the angle between AI vector and AI prime vector must be equal to pi over 4. If you look here to the figure, you see that the triangle AIO is a right isosceles triangle, and you can prove it easily. So, in a right isosceles triangle, we have a property that the hypotenuse equals side radical 2. So, AO equal AI times radical 2. So, AO equal radical 2 AI, and this matches with the first condition. Now let us see that if the angle between AI and AO, if it is pi over 4 or not. Yes, the angle between the vectors AI and AO is pi over 4 because the diagonals of the square bisects the angles of the square. So the angle IOA will be pi over 4. So the angle between the two vectors AI and AO will be pi over 4. So this means that O will play the role of I prime. So S of I equal O. And this is the solution. S1 of I equal O because AO equal radical 2 AI as we said, and AI AO equal pi over 4. Now let us go to the second one, S2 of O. First, S2 is of center B, ratio radical 2 over 2, and angle pi over 4. By the same way, you must find a point O prime such that BO prime equal radical 2 over 2 BO, and the angle BO prime equal pi over 4. If you search here in the figure for this point, it seems that it will be I. So S2 of O equal I, and this is because BI equal radical 2 over 2 BO, and this is because, as we know, again in the right isosceles triangle, the hypotenuse BO will be equal to radical 2 BI, so BI equal 1 over radical 2 BO. If you rationalize this fraction 1 over radical 2, it will be radical 2 over 2 BO. Now, the angle BOBI is equal to pi over 4, and you can prove it easily. S3 of D, yes, S3 is of center A and ratio half and angle minus pi over 2. So you must find also a point D prime such that AD prime equal half AD, and also the angle between AD and AD prime must be equal minus pi over 2. Yes, this point will be I, and this is because AI equal half AD, and it is easily to prove that. Also, AD AI will be equal minus pi over 2 because the angles in the square are right. Now the second part, deduce that S2 round S1 round S3 of D is equal to I. How to do that? Think and try to solve it before you see the solution. Yes, S2 round S1 round S3 of D equal S2 of S1 of S3 of D. As we know that we proved S3 of D is I, so S2 of S1 of I is equal to S2 of O because we proved that S1 of I is O. Finally, S2 of O will be I because we proved that S2 of O is I. Now, let us see this property. Given the direct plane similitude S with center O, ratio K, and angle theta, so we have this property, S of A equal A prime and S of B equal B prime, if and only if A prime B prime equal KAB, and the angle between AB vector and A prime B prime vector is equal to theta mod 2 pi. Example, before we solve this example, this property helps you to find the ratio and the angle of given similitude S, and we will see that in this example. Let ABC be a direct right isosceles triangle such that AB vector AC vector equal pi over 2, IJ and L are the respective midpoints of AB, AC, and BC. Given S is direct plane similitude that transforms I onto L and L onto C. Here is the figure. The question is find the ratio and the angle of S. First, we will start from this given that this S transforms I onto L, and also it transforms L onto C. That means S of I equal L. Also, S of L equals C. So we have here the images of 2 points by S. From this, we can find the ratio and the angle of this similitude. How to do that? First, to find the ratio, define the image segment by the pre-image segment. Means divide LC by LI. So the ratio K will be LC divided by IL equal LC over JC. And we can prove easily that YIL equal JC. IL is equal to half of AC by midpoint theorem. And since J is the midpoint of AC, so IL will be equal to JC. Now YLC over JC equal radical 2. As we said before, that in a right isosceles triangle, the hypotenuse is equal to side times radical 2. So BC equal AC times radical 2. But BC equal to CL and AC equal to JC. So LC over CJ will be equal radical 2 as required. So we found the ratio K. Now how to find the angle? To find the angle of this similitude, you must find the angle between the pre-image vector IL vector and the image vector LC vector. So theta will be the angle IL LC. If you want to find this angle, use some geometric properties. First, try to keep that the first letter here of the vector must be same as the first letter here of this vector. So it will be equal to minus Li LC vector. But we have a property in oriented angles that the angle minus Li LC will be pi plus Li LC. Now how to find the angle Li LC? This is Li and this is the LC. You can match here L with J. Here the angle is 45 degrees and here the angle is 90 degrees, and you can prove it easily. So the angle between Li and LC will be minus 3 pi over 4 because it is oriented in negative sense. So finally theta will be pi plus minus 3 pi over 4, it will be pi over 4. So in every time to find the ratio and the angle of a certain similitude, try to search for the images of 2 points by this similitude, and from these images you can find the ratio by dividing the length of the image segment by the length of the pre-image segment. And to find the angle of this similitude, find the angle between the pre-image vector and the image vector. Now let us go to this application. Given a direct square ABCD with I the midpoint of segment AB, here is the figure. Given the similitude S that transforms I onto B and B onto C, find the ratio and the angle of S. Please stop the video, solve it before you see the solution. Yes, as you said, S of I equal B and also S of B equal C. So as we said in the previous example, to find K, divide BC by IB. So K equal BC over IB. So K equal 2, and you can see it easily in the figure that BC is twice of IB. Now the angle theta will be equal to the angle between the two vectors IB and BC. Write the angle such that B is the initial point. So it will be minus BI vector BC vector. It will be pi plus BI BC vector. But BI BC vector is minus pi over 2. So the angle will be pi plus minus pi over 2. Thus the similitude S is of ratio 2 and angle pi over 2. And the missing element is only the center of this similitude. Now the second part, construct L the center of S. Also try to solve it alone. Again, S of I equal B. Here we will use a geometric property that we had learned in grade 9, which is when we have a right angle, then the vertex of this angle will be on a circle of diameter determined by the extremities of this angle. So here, since S of I equal B, so Li vector, Lb vector will be equal to pi over 2. So L will be on a semicircle C1 with diameter IB. Deprive from I and B, that means L can't be I and B. And why we say semicircle? to keep the oriented angle here in positive sense, because the angle of the similitude is pi over 2 and it is not minus pi over 2. So you see here we have a semicircle of diameter IB. If we use this idea again, that means we have S of B equals C, so that means LB LC will be equal to pi over 2. So again L belongs to another semicircle C2 with diameter BC deprived from B and C. And this is the figure. So the green semicircle C1 and the blue semicircle C2 will intersect in a point. This point will be L, and it can't be B because we said that L is deprived from B. So finally the similitude S is of center L, ratio 2 and angle pi over 2, and we determined geometrically the position of L as you see in the figure. Property 2, let K be a strictly positive real number and theta be a real number, S be a direct plane similitude with center O, ratio K and angle theta. If we have a similitude of center O, ratio minus K and angle theta, this similitude will be of center O, ratio K and of angle pi or minus pi plus theta. Definition 2, a direct plane similitude S of center O, ratio K and angle theta is the composite of a dilation of center O, ratio K and a rotation R of center O and angle theta, or it will be a translation. This is an example 3. The question is, identify the characteristic elements of each of the given similitudes. First example, S of center A, ratio minus 2 and angle pi over 5. Yes, S will be equal to a similitude of center A and ratio 2 and angle which is minus pi plus pi over 5, which is minus 4 pi over 5. So in order to remove the negative sign from the ratio, it's enough to add or subtract pi to the angle of this similitude. The second part we have here, S is the composite of a dilation and a rotation of the same center and of ratio 2 and angle pi over 5 respectively. Yes, S will be a similitude of center A, ratio 2 and angle pi over 5. Another application 3, also identify the characteristic elements each of the following similitudes. S here is the composite of a rotation and a dilation. Yes, S will be a similitude of center B, ratio half, and angle minus pi over 3. And all these rules are according to the property 2. Also, this is another example. S is the composite of a rotation and a dilation. So S will be of center C, ratio minus half and angle minus 2 pi over 3, but since the ratio is minus half, so we can remove the negative sign, so it will be a similitude of center C, ratio half, and of angle pi minus 2 pi over 3 by adding pi to this angle. Note, sometimes we add pi, sometimes we subtract pi in order to keep the measure of the angle of the similitude in principal measure. Now, given the similitude S of center O, ratio K and angle theta, the similitude preserves collinearity, midpoints of segments, parallelism, orthogonality, measures of oriented angles, and shapes. But on the other hand, the similitude doesn't preserve distances and areas. In fact, if A prime, B prime, C prime are the respective images of ABC by S, then A prime, B prime is equal to absolute value of K multiplied by AB, which is equal to K times AB if K is strictly positive, and the area of A prime, B prime, C prime will be K squared multiplied by the area of the triangle ABC. Given this application 4, complete by true or false, we have here some similitudes of different ratios and different angles. Try to complete it alone before you see the solution. The first similitude S is none of these types. It is not identity, it is not rotation, it is not dilation, and it is not symmetry. The second one, it is a rotation because its ratio is 1. The third one is a dilation because its angle is 0. The fourth one, it is a rotation because its ratio is -1. So it is a rotation of angle pi or minus pi, and also it is a dilation because its angle is 0. Also it is central symmetry because if the ratio is -1, we can say that the dilation is central symmetry. The last one, it is identity because the ratio is 1 and the angle is 0. Also it is the rotation Also, it is a dilation, but it is not symmetry. Now let us see here what Mira and Rima said. Application 5 in the figure to the right, ABCD is a square with center O. I and J are the midpoints of AB and AD respectively. S is direct similitude such that S of I equals C and S of J equal A. Determine the ratio K of S and the angle theta of S and find S of A. First, Mira wrote, since S of I equals C and S of J equal A, so she divided CA by IJ to find the ratio, and it seems that the ratio is 2, and to find the angle between two vectors IJ and CA, which is equal to the angle between OD vector and 2OA, because the vector CA is equal twice OA vector, and the angle between OD and OA is pi over 2. And also she said that S of I equals C and S of J equal A, and this is the given, and to find S of A, she said that S of A equal A prime, and since the triangle IJA is a direct right isosceles triangle at A, so the image will be also a direct right isosceles triangle. So you must find a triangle CAA prime, which is right isosceles triangle, and it is also direct, and this triangle will be CAB. So that means A prime will be the point B. So S of A equal B. Now Rima said, again by the same way she found the ratio and the angle, but to find A prime, which is the image of A, she wrote S of I equal C and S of A equal A prime. So the angle between the vector IA and the vector CA will be pi over 2, which is the angle of the similitude. That means this vector is perpendicular to this vector. So IA is perpendicular to CA prime. That means A prime will vary on a straight line passing through C and perpendicular to IA. That means A prime will move here on this straight line, which is CB. So she said, or CB, to define this line. So A prime will vary on this line. And by the same way, she said S of J equal A and S of A equal A prime. So again, the angle between JA and AA prime is also pi over 2. Then also A prime moves on a straight line passing through A and perpendicular to JA, which is AB. So A prime will be on this straight line AB. So A will be the intersection of these two straight lines, CB and AB, which is B. So S of A will be B. What do you think? Which one did you like? Here is your assignment. Here is the summary. Thanks for listening. See you soon. Assalamu alaikum wa rahmatullah.